Okay, guys, let us start our stream. I hope so that I am live already. Um, I believe I'm live. Yes, I'm live. So, hey guys, welcome back to our channel Coders Arcade, and this is Ashang David. And in today's video, we are going to talk about graphs. Okay, so I'm gonna use my this. Okay. All right, guys. So we are live right here. Okay. Okay. So yeah, welcome back to Coders Arcade, guys. This is Ashank David, and let us start our live stream. Our live session is going to be on graphs. Today we are going to learn about graphs. We will talk about its introduction and let us see what all things we can do. So, guys, this was the most awaited live session, and we will start our session in a few minutes. People are joining, I can see. Okay. Okay, so we can start. So welcome guys, welcome back to Coders Arcade. This is Ashank David, and in this live session, welcome to the session number 33 of this live session. And we are doing placement series for DSA, where we study about the DSA concept and we try to implement it. I will be explaining you all the things about um, that particular concept. So in today's class, we are starting with graphs. Now, before I start with this video, guys, before I start with this live session, I would like to request you people to please like, share, and subscribe to our channel, Code is Arcade, and don't forget to press the bell icon so that you won't miss any future updates. And share this live stream as much as possible so those people who really want to learn about DSA all for free, this session may help them. As well as apologies and just bear with me for this kind of setup. I am right now out of station and I am not available in my office, so I don't have my setup right now with me. So for the time being, I am doing directly live from my laptop, and yeah, so it is going to be a little bit like this for this week. So bear with this, guys, and I will continue. And don't worry, quality won't be compromised. That I will take care of. We will try to understand a lot of things in today's class, and today's class is not going to be too long because this is just an introductory class, and I am going to just explain about how graphs work and everything works. I hope so that I'm audible, I'm visible, and my screen is very clearly visible, guys. So let us start. If you have any problems related to my live stream, if I'm not visible or if I am not uh, audible, then please do let me know. Okay. Well, in today's class, we are going to start with graphs. We are going to talk about the introduction part. So exactly, graph is what? It is a type of it is a data structure. Data structure. Okay. Where the data is stored inside the nodes. Nodes here. Just like we have our linked list, we have our graphs where nodes are used, or maybe like a tree where we use nodes to store our data. Now, all the trees, trees, they look like this, right? Correct? Binary trees, binary search trees. We have already done a lot of things, right? And we have understood. So if you haven't watched our trees concept live session, I have done trees concepts also. So if you have not seen, then I would highly recommend to go back and see our trees live session as well. Well, as of for now, this is how where trees were looking like, where we saw that this is the node. and this is the branch, and this was the root. Okay, we have understood till here. Now, tree is also a kind of graph only. Do you know this? That all the data structures which we have done before are some or the other kind of a type of a graph only. Linked list is also a type of a graph. Trees, in fact, is also a type of a graph itself. But here we are into finally our concept of graphs, and graphs here we are going to talk about in too much of depth. So let's start with this, specifically related to the types of graphs which are asked in placements and interviews. Okay, guys. So let us talk about that. So graphs, yes, it's a data structure, and the data is stored inside the nodes. Okay, real-time uses can be it is used to handle very complex scenario where data has to be organized, and this is the place where we use graphs basically. Okay, how does a graph looks like? A graph can look like anything. This is a node, and just a node in a space is also called a type of a graph, whereas this type of graph is also called as trivial graph. Okay, but yeah, um, we are going to talk about proper graphs. So we have the node itself, and the node is connected with the help of a edge to another node. So in this case, this is called as EDGE, edge. Okay, guys, this is called as edge. So basically, in this case, this is a linear kind of a graph. But in general, graph in general is a type of a non-linear data structure. Okay, guys, this is also a graph where these are the nodes and these are the edges. This is also a graph, okay, where these are the nodes and these are the edges. I hope so that everyone is getting my point of what and how the graph data structure looks like. Okay, guys. So we'll go ahead a little bit further into this. In general, graphs, a real world example, best real world example can be Google Maps. Google Maps, where the data is stored in a form of a graph only. You see this kind of a graph. Okay, this is also a graph where this can be a city, which is our data, and these are the edges, or you can say roads, connecting multiple cities all together. So these red ones are nodes or cities basically. Okay, guys, and these white lines are what you call as these green lines are what you call as the edges basically, or roads in this case, and data in this case, like this. Okay, this is a type of a graph. So graph is actually used in these kind of places to store a very complex data in real life, to manage that, organize that complex data in order to achieve some kind of a feature out of it. Now there are ways of doing operations onto the graph. You can do traversal, You can do cycle detection. You can do basically you can do a lot of other algorithms related to graphs, such as very popular one is Dijkstra's algorithm. People call it a Dijkstra's algorithm. Okay, Dijkstra's. Or maybe you can find the shortest path distance. So for shortest path, you have many different types of algorithms like prims, which finds the minimum spanning tree. Dijkstra's is also one of the minimum shortest path algorithms. Okay. Then we have Kruskals. Then we have Bellman Fort and etc. etc. There are lots. Okay, there are a lot of types of algorithms that you can study on graphs. Okay, guys. Slowly we are going and trying to understand how it works. Speaking of, generally, majorly types of graphs that we are going to study in this course is going to be, let us say, imagine this is a graph. Of course, this is of course a graph where this node is marked as U and this node is marked as V. Now here you see that there is just edges and nodes. So we will call it as undirected graph. Undirected graph. What do we call it as? Undirected graph. When I give the directions in the edges, so for example, from here to here we are going, and then from here to here we are going, and then from here to here we are going, and from here to here we are going, and then from here to here we are going. Okay, this is called as directed graph. Let me just clear it off properly. Directed graphs. Okay, where now the directions are given. Okay, where here this is undirected because there is no directions given. Okay, when we talk about in the same graph, let us say, when we talk about paths, paths, there is a node between, there is an edge between U and V. We say in this case our path is equals to U to V and V to U. We know this that this is an undirected graph. In terms of undirected graph, because it is undirected, we can go into both ways, both direction, both ways. Are you guys getting my point? If you have any doubts, please do let me know. Okay. But in this case, when we are given with the direction U to V, we say path is equals to U to V only. There is no backward path because this is directed graph. Here we have only one way, from that is U to V. I hope so that this is very much clear to all of you. Okay. Now, if we talk about degrees, let us say we have this graph. Let us say we have this graph where this is the node, these are the nodes, and these are the edges in between. Okay. Now, if I say this is U, this is V, this is Z. Let us say this is Z. U, V, Z we have, for example. If I ask you, tell me the degree of u, you will say the degree of u is 2. Understood my point? Understood this, guys? The degree of u is 2. What exactly is degree? Here, degree is just the number of edges either going inside the node or coming outside the node, or in a general, total edges connected to a particular node is what you call as degree. I hope so that this is very much clear to you guys. If I say, tell me the degree of v, let us say here we have x also. Okay. So now if we say degree of v, then it will come as 3. Because you see that there are 3 nodes connected to v. And here we have only 2 nodes connected to u. So 2 nodes for degree of u, and there are 3 nodes for degree of v. I hope so that this is very, very much clear to all of you. Okay, guys. Correct. Now we are talking about degrees, and here we talked about degrees in an, this is what? It is an undirected graph. Okay. Now we are going to talk about directed graph. So I said, now we have a directed graph. Okay. So here we have the directed graph. So this is u, this is v, this is z, this is x, and you see that some directions are given. Now in this case, their degrees will be divided into 2 types. First is in a degree, and next one is out degree. In a degree and out degree. In degree is how many nodes are going inside. How many nodes are going inside. So if I say in a degree of v, it will be 2. Okay. And if I say out degree of v, it will be 1. Because you see that the out degree of v is equals to 1. Why? Because you see that there is this which is going outside the v and coming in this way. And there are 2 places where v, there are 2 in degrees coming towards v. I hope so that this is very, very much clear to all of you. Okay. Similarly, if you see for in a degree of u, you will say 0. Say out degree of u, you will say 2. Because no node or no edge is going inside v, but only coming out from I'm talking about you. So there are no end degrees, or there are no edges going inside you, but there are two edges coming from inside of you. Okay, this is what you called as in degree and outer degree. I hope so that this is also very much clear to all of you. This is the just the theory part which I'm telling you for graphs, which is important, guys. So these are the terminology that we are going to use later on. So remember that this is how it is gonna be done. Okay. So now let us continue into more depth of things. Okay. Now any graph that you have, let us say this is our graph. Now let us say this is u, this is v, this is x, this is z. Okay. And there are some numbers given onto the edges. Let us say this is 2, this is 3, this is 5, this is 7, this is 4. Okay. In this type of situation, these are called as weights. These are all weights. Okay. What is weight? Weights are, so I'll tell you right here. What are weights? First of all, we will call this as undirected weighted graph. Okay. And on the other hand, if I say, let us say that this is our graph. Okay. And there are the same weights present over here also. Let's imagine. You can take any random number. I'm just saying. Here, these are the weights. All the numbers are the weights here. Whenever there is some number given onto any of the edge of the graph, it is called as weight. This will be called as directed weighted graph. Okay, okay, guys. I hope so that this is very, very much clear to all of you. Now, I talked about weights though, but I did not tell you what exactly is weight. So, weight, handwriting. Okay, so here basically weight, weight, weight is the distance between two nodes. Okay, the higher the weight, more the distance between two nodes. Similarly, lower the weight, lesser the distance between two nodes. Okay, guys, I hope so that this is very, very much clear to all of you. Okay, so this is weights. I hope so that this is very, very much clear to all of you. Okay, now, now, we will talk about types of graphs you can talk about in general. Now, there are a lot of types of graphs, guys. Okay, there are lots and lots of types of graphs. Some of them I'll be telling. Okay, one more thing I did not tell you before I go ahead into this. Weights I told about this. Okay, weights I told about degrees I told about directed, undirected, paths. Okay, a lot of things I've told you about graphs, but I did not tell you about when you have, let us say, this graph. Okay, this type of graph is called as acyclic graph. Acyclic graph, where you see that we are able to go from here to here, but now it is gonna come from here to here. That means the cycle is not getting formed here. Like we see that all the nodes are connected to each other in an equal state, but the directions they don't favor towards allowing us to travel from one node to the last node or the one node to the node itself. If the node, if you start from a particular node and you end up on the same node, it becomes a cyclic graph. But this is an acyclic graph because there is no cycle present between, kind of a cycle, but you cannot reach back to from where you started. This type of graphs are called as acyclic graph. On the other hand, this type of graph is straightforward called as cyclic graphs. Okay, because you see that we can start from here and we can reach back right like this. Okay, so that's the difference here. Okay, when you start from a node and end up reaching end up reaching the same node, then that is a cyclic graphs. Now guys, later on there are algorithms for them. Okay, we can detect cycle is present in the graph or not using, we have cycle detection algorithms. Okay, okay. We can detect cycle is present in the graph or not using cycle detection algorithms. In future, we are going to study cycle detection algorithms. I hope so that this is very, very much clear to all of you. Okay. Now, if we talk about the, if we talk about the, if we talk about the traversal, traversal in a graph, traversal in a graph, then a graph can be traversed. Let's say this is your graph. A graph can be traversed just like, just like trees. Yes, there are different graphs traveling techniques like In graphs also you have both BFS and DFS. Okay, so we will talk about this later on. So V, U, V, X, Y. Now I can say here you started from U, then you went up to V and X, and then at last you travel towards Y. Okay. And for DFS, you can say U, then V, then Y, then X. The, okay, wait. Small note here. The, or I'll say like this, your traversal answer can be different each time you travel from a node. Your traversal answer can be different each time you travel from a node, but also correct. So no worries, no worries. Different traversal, because here in graphs, because in graphs there is no starting node. In graphs, there is no starting node, guys. I hope so that this is very much clear to all of you guys. Clear? Okay. So therefore, therefore, I hope so that we are still live and it is going. Yep, it is still live and yeah, we are up. We are still live, I guess, right? Yep. We are still live. Okay, no worries. There is no starting node. So there can be there can be multiple um multiple um what do you say, ways to travel in a graph. Okay, guys, I hope so that this is very much clear. So here answer and travel from node, but also correct. And here it is no starting node. Okay, guys, I hope so that this is very much absolutely clear to all of you guys. Okay, now, 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 now. We are still live, right? Yep, we are still live, but uh, I hope so that there's no issue with the connection. If you have any issues with the connection, please do let me know. Okay, we are live actually. Correct. Hmm. Okay. Okay, fine, guys. Let's continue. So there can be different traversal techniques as well. So no worries. Both BFS and DFS we will study in future. Let's move on and let us understand more about it. So guys, speaking of this, when we are talking about types of graphs, now there are many types of graphs. We're going to talk about some graphs. We have trivial graph. Trivial graph. Trivial graph means just one node. This is what you call as trivial graph. Just single node without edges. Okay. Number two, we can have directed graph. For example, this is a directed graph. Number three, we have undirected graph. So we have two connections like this. So this is also a graph only. Okay. Number four, number four, number four. We have connected graph. Connected graph. Connected graph means everything is connected no matter what. Everything is connected. Now, connected in the sense not every node should be connected to each other. This is a connected graph. Number five, you have disconnected graph. In this type of graph, there is this node, then there is no connection between this node, and these nodes are connected. Somewhat like that. Understood my point? This is a disconnected graph. Number six, regular graph. Regular graph. A graph which has equal number of edges connected to each node. You see, there are still two nodes connected here also, two edges connected here also, two edges connected here also, and two edges connected here also. So you see that each and every node has equal number of edges connected to each other. That is a regular graph. Okay, guys, understood my point? Complete graph, regular graph, whatever you would like to say. Okay, cyclic graph. Cyclic graph. Cyclic graph. There is a cycle present. Okay. Now, cycle can be present in undirected also. That's also correct. In undirected also cycle can be present, and directed also cycle can be present. I hope so that this is very much clear. So you can say uh, directed cyclic graph. Here we can create a undirected cyclic graph. Okay, where this is your undirected cyclic graph. 9. Acyclic graph. Acyclic graph. Where the cycle is, it seems like the cycle is present, but actually cycle is not present. It is not possible for us to meet. I hope so that this is very much clear to all of you. Clear? Okay. Then we have something called as bipartite graph, where there are two groups. There are two groups. Okay, and there are some nodes in both the groups. The funda is that they can connect with each other group's nodes, but they cannot connect with their own group's nodes. So this cannot be possible. Understand my point? Let me do it like this. This cannot be possible, but this can be possible. I hope so that this is very, very much clear. to all of you. Correct. So this is not possible. This is not possible. And now these are some of the graphs that everyone knows and remembers. There are etc, various different types of graphs. But these are the graphs which are generally asked in interviews. I hope so that this is very, very much clear to all of you. Okay, quickly let's move on to the main thing, graph representation. Graph representation. Okay, guys, mathematically in maths, graphs are represented by g of v comma e. So if this is the graph, let us say if this is the graph, then this is gonna be g of 4 comma 4. This is v for vertices and e for edges. Here v means vertices or nodes, okay, and e for edges. I hope so that this is very, very much clear to all of you. Absolutely clear, right? Right, guys. Yes, weighted graphs. Weighted graphs. Ah, etc. Weighted graphs can be there. Unweighted graphs can be there, etc. etc. Yeah. D Ayush. Yes. Okay. Majorly, this is how you represent the graph in maths, in mathematics. But in general, in terms of computer science and in terms of code writing, we represent the graphs by two types. Number one, adjacency matrix. And number two, adjacency list, we call it as. Let's talk about this, guys. Very important concept of today's class. Number one, let us talk about adjacency matrix. Adjacency matrix, guys, what exactly is this? Let us say you have a graph like this, like this, like this, like this. Okay, guys, this is U. Let's not take U. Let's take this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So I've just put some numbers into the graph nodes right now. Adjacency matrix is you create a matrix of n by n. How many nodes are there? 6 nodes are there. So let us do one thing. Let us start it from 0. Let us actually start it from 0. I said this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. Okay, let us say these are the numbers. 0, oops, let us color them. Okay, this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. Okay, now, guys, let us say we need to create the adjacency matrix. How do we create the adjacency matrix? You will create 0, 1, 2, 3, 4, and 5 like this. And 0, 1, 2, 3, 4, and 5 like this. Okay. Rows and columns you will create. I hope so that this is very, very much clear to all of you. Okay. Let us do one thing. Let us create a smaller one. Actually, this became way too big. Okay, so I said 0, 1, 2, 3, 4, 5. This is these are the columns. Okay, so write like this, write like this, and write like this, write like this, and write like this. And yeah, this will be a little bit bigger. Okay, then you have these ones. Uh, Let me just create it properly, nicely. Okay, one more will come right here. Okay, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. Okay, so this is your matrix. Okay, guys. Hello, sir. Ronnie plays. Hello, hi, hi. Hello. Okay, so here now, when there are no weights given, you assume the weights to be 1. No problem. Whatever. So this is the graph. If the weights are given, you put the weights and those weights has to be filled up here. Now see, is there an edge between 0 to 0? Is there is an edge between 0 to 0? No. So you write here 0. Is there any edge between 0 to 1? Yes. So you write the weight right over here. That weight will come. Is there any edge between 0 to 2? No. Edge between 0 to 3? No. Edge between 0 to 5, 4? Yes. Edge between 0 to 5? Yes. Is there any edge between 1 to 0? Yes, because this is undirected. So 1 to 0 also I can go. So I can say the edges from 0 to 1 and 1 to 0 also vice versa. 1 to 1? No. 1 to 2? 1 to 2? We have? Yes. 1 to 3? Yes. 1 to 4 do we have? Yes. And 1 to 5 do we have? No. 0. From 2 to 0 do we have? No. From 2 to 1 we have? Yes. From 2 to 2 we have 0. 2 to 3 we have? Yes. 2 to 4 we have? No. 2 to 5 do we have? No. 3 to 0? Nope. 3 to 1? Yes. 3 to 2? Yes. 3 to 3? No. 3 to 4? Yes. And 3 to 5? No. Similarly, 4 to 1. Is there any? Yes. 4 to 4 to 2. 4 to 0. Sorry, 4 to 0 is there? Yes. Then 4 to 1? Yes. 4 to 2? No. 4 to 3? Yes. 4 to 4? 0. 4 to 5? Yes. Last. 5 to 0? Yes, it is. 5 to 1? Nope. 5 to 2? Nope. 5 to 3? Nope. 5 to 4? Yes. And 5 to 5? 0. I wanted to check for 1. 1 to 0? Yes. 1 to 1 to 0? 1 to 0? Yes. 1 to 1? No. 1 to 2? Yes. 1 to 3? Um, nope. Yes. 1 to 4? 1 to 4? Yes. And 1 to 5? Okay. Yes. This is going to be your, guys, this is going to be your adjacency matrix. This is adjacency matrix representation of graph. I hope so that this is very much clear to all of you. This is gonna be your answer, answer, matrix. Answer matrix or answer whatever you will call. This is the graph adjacency, the graph representation as adjacency matrix, guys. Now let's do one thing quickly. Take the same graph, copy this, and let us do, let us do adjacency list. Last for today's class. I'm gonna paste that right over here. Okay. And let us create our adjacency list quickly. Okay. Same thing. But in this case, guys, what do we do? We note down all the nodes. We note down all the nodes. 0, then 1, then 2, then 3, then 4, then 5, then 5. Okay. So note down all the nodes and tell who all are the neighbor of 0. 0's neighbor is 1, 4, and 5. So right here 1, 4, and 5. 1, 4, and 5. Then who all are neighbors of 1? 1 has 0, it has 2, it has 3, it has 4. Okay. Who all are the neighbors of 2? 2's neighbor are 1. Then we have 3. That's it. That's it, guys. Okay. I hope so that this is very much clear. Who are the neighbors of 3? 3's neighbors are 1, 2, 4. Got it, guys? And then who all are the neighbors of 4? So 4's neighbors are 0, then 1, then 3, and then 5. Okay, guys? Who all are the neighbors of 5? We have 0, we have 4, that's all. And guys, this is your this is your answer. I hope so that this is absolutely clear to all of you guys. Okay, guys, answer. This is your, this whole thing is your adjacency list representation of graph. I hope so that this is very much clear. Bus, that's all. This is how you represent graphs. Well, we have understood this now that this is a graph and a graph can be represented in many different ways. First of all, we have understood the First of all, we have understood the mathematical way. Then we have understood the mathematical way was this one, correct? This one was our mathematical way. And then we have understood about adjacency matrix. This is the first way of representing the graph. And then comes your adjacency list. This is the second way of representing the graph. Okay, guys, I hope so that this is very much clear to all of you. Today, that's it for this much for today's class. This much is enough for today's class. We have done a lot of things, a lot of theory about graphs. From tomorrow's class, I'm gonna show you some programs and we'll try to understand how that works. I hope so that this is very much clear. Hi, sir. Hello, sir. Hi, adjacency matrix is created using 2D arrays. Yes, yes. Adjacency list is created using list. Yes, D. Ayush. Bhumika Lokesh, hi sir, hi Bhumika. Then D Ayush, adjacency matrix is created using 2D arrays. Yes, two-dimensional arrays. You can use two-dimensional vectors also. This is why I was teaching you vectors. All right, D Ayush. I hope so that you have got my point. Then adjacency list is created using list. Yes. No, actually adjacency list is created using list. I'll tell you about it. Adjacency list is created, can be created using vectors also and maps also. So that is the main reason. That was my main reason to tell you about vectors and maps in graphs data structure. But guys, I hope so that this is so far is clear, very much clear to all of you. And we have done a lot of theory concept in today's class. I wanted to have a dedicated theory class on graphs because this is the prerequisite knowledge that we should know about graphs before we go ahead any further into the coding of graphs. So very important, guys. I hope so that today's class is very much understood. We talked about graphs, we talked about weights, we talked about types, we talked about paths, we talked about degrees, we talked about traversal in the graph. We have talked about types of graphs. We have talked about graph representation. We have talked about adjacency matrix, adjacency list. A lot of things we have talked about in today's class, guys. Well, thank you so much for watching this live stream, guys. I hope so that this is absolutely clear to all of you guys. And that's all. About any doubts, I'll be watching your comments below. And any doubts, please let me know. We can meet again in the next class tomorrow, same time, 6 o'clock Indian Standard Time, guys. Thank you so much for watching. Don't forget to like, share, and subscribe to my channel, Code is Zakir, and don't forget to press the bell icon also so that you won't miss any future updates. And also, don't forget to subscribe to our Telegram channel. Telegram channel is very important. In Telegram channel, we provide a lot of things like study materials, um, updates about our interview sessions, placements, and a lot more things. So if you're not subscribed Coders Arcade Telegram channel, please do like and subscribe our Telegram channel. The link is already provided in the description below, and we are again starting our DSA batch very soon. So if those people who are really interested in joining our DSA batch, please do let me know. I'll be the one who will be teaching DSA, and we will be finishing the course in really small time. Will more things, sir? What we learn after graphs? We will see, Ayush. We will see. So graphs is very lengthy and very important topic. Just like how trees happened, graphs will also go like for 1 week around, and we will see what all things we can do. All right, Ayush, and yeah, that's it. Thank you guys so much for watching. I will see you again, guys. So tomorrow I need to go right now, and I'll be stopping in this live stream. I will come back again with a new concept tomorrow, and tomorrow we'll go into more depth of graphs and understand each and everything about graphs. I'll be sharing this PDF which I have created just now. I'll be sharing the link of this whiteboard right away, and you can refer to this whiteboard. This is my handwritten notes, guys. These are all my handwritten notes which you can use to learn, and yeah, like this. These are the study materials that we have. So, well, that's it, guys, for this class. And thank you so much for watching. If you have watched this live stream till the end, then thank you guys so much. Well, that's it, guys, for this today's live session. I'll see you guys again tomorrow at the same time, 6 o'clock, 6 p.m. in the evening, Indian Standard Time. And we'll see. That's all, guys. This is Ashank David signing off. I'll see you in the next one.